Today I will discuss about various types of system. At first we see the homogeneous system. The physical and chemical compositions of this type of system is same in every sphere or every space of the system. In a system, in every sphere of the system, the physical and chemical composition. Physical composition means its state, like temperature, like solubility, and chemical compositions are like the ratio of hydrogen oxygen or the ratio of the nitrogen oxygen, etc. These are called the chemical composition, and another the states are called the physical composition. As an example, syrup made up with sugar and water. A syrup made up with sugar and water. It is a homogeneous system because syrup is taste sweet. The sweet taste of the syrup is every sphere of the system. Pure metal is like a sodium. Sodium a pure metal, and it is pure in its every sphere of the metal. And the composition is also same in every sphere of a piece of sodium metal. Okay. Now heterogeneous system. The physical and chemical composition of this type of system is not same in every space or sphere of this system. Physical and chemical composition of this type of system is not same. Okay. In every space or every sphere of system. As an example, a mixture of sugar and NaCl. Sugar and NaCl. NaCl is salt and sugar is a sweet taste. So taste and the composition of this mixture is different in every space of the system. It is also a heterogeneous system, and sugar is a carbohydrate, so the composition is different from the NaCl because the composition of NaCl is Na and Cl. Okay, NaCl is formed by Na and Cl, so the composition of NaCl and sugar are also different. The mixture of water and benzene. Water is a liquid form and benzene is also liquid form, but benzene is an organic compound and water is an inorganic, we can say inorganic compound. So these are the two different types of composition. So mixture of water and benzene is a heterogeneous system. Macroscopic properties. The system made up with big atoms, molecules or ions is called macroscopic system. Macroscopic system, the system which is formed by the big numbers of atoms, big molecules or ions are called the macroscopic system. Like some water, some gases, the mixture of some gases like nitrogen gas, oxygen gas and hydrogen gas. The mixture of these gases are called the macroscopic properties. Okay, macroscopic system and macroscopic properties are the two types. One is the quantitative properties and another is the qualitative property. So quantitative properties are mass, volume, mole number of a system, and qualitative properties are the pressure, temperature, etc. of a system. Okay, surface tension, etc. These are also qualitative properties. So quantitative properties depends on the amount of the material or element. The material is how much in quantity. It is called the mass. The how much mass of this sugar or what volume is gained by the oil in a container. Okay, so this is the volume. Mole number is also how much mole, what is the number of moles water molecules in a glass of water, if you ask. So then this is called, we can give an answer with mole numbers. Okay, so this is the quantitative properties, and qualitative properties are the pressure, temperature, surface tension, what is the pressure of the air today, what is the moisture in air today. So this are the qualitative properties. It depends on the physical properties of the system. A system in which qualitative properties, it depends on that. Okay, quantitative property may be qualitative property, but when? Okay, sometimes we can see that quantitative property of a system is equivalent to qualitative property of a system, but when it will be? So here now mass equals to small m. Mass is denoted by small m, volume is denoted by small v, and density is equal to mass by volume, okay, small m by v. So the ratio of the two quantitative property, we know that mass and volume of a system are the quantitative properties. So ratio of the two quantitative property means a qualitative property, density. Density is a qualitative property, the density of water. So it is a qualitative property also. So here the qualitative property becomes equivalent to the ratio of the two quantitative properties. Okay, internal energy is equals to the quantitative property. Internal energy for 1 mole substance is equal to internal energy per mole. Okay, so for 1 mole of the substance, internal energy is equivalent to the quantitative property. The internal energy for the 1 mole substance is equal to internal energy per 1 mole, মানে per mole, অর্থাৎ হচ্ছে 1 mole for 1 mole substance internal energy is what? It will be denoted by the internal energy per mole. Okay, it is a qualitative property also. Now thermodynamic properties. Thermodynamic properties are the physical properties by which we can explain any state of a system completely. Those are called thermodynamic properties. The physical properties by which we can explain any state of a system. The physical properties like the pressure, temperature, surface tension, those all can be explained completely by those properties. Okay, these are called the thermodynamic properties or variables. Those variables must be measurable. The variables are also measurable. Okay, now pressure, volume, temperature and composition must be notable to indicate the thermodynamic properties. The pressure, volume and the temperature and composition must be notable. The pressure, volume and temperature, we can note the pressure with barometer. In case of air, we can measure the pressure with a barometer. Temperature can also be measured by thermometer, and volume can be measured by volumetric flask, etc. So the composition also must be noted to indicate the thermodynamic properties. Thermodynamic properties are also here notable. Okay, now thermal equilibrium. If the temperature of every sphere of a system is same with the temperature of the environment, then it is called the system is in thermal equilibrium. If a system is in same temperature with the temperature of the environment, the temperature of environment and the temperature of the system is same, then it is called at a time a time is come for a system when the temperature of the system and the temperature of the environment is same. This time the system is called in thermal equilibrium. This time the system is showing us the thermodynamic equilibrium. Okay, or the thermal equilibrium. Okay, now mechanical equilibrium. If any unbalanced force does not work between the system and the surrounding, then it is called the system is in mechanical equilibrium. If any unbalanced force does not work between the system and surrounding, like if the transfer of energy from a system and surrounding is occurring, then it is then we can say that it is not in mechanical equilibrium. If there is no transfer of energy, no transfer of any types of molecule or any types of volume, okay, with the environment and system. Between environment and system there must be a transfer of the volume or transfer of the any materials or temperature, etc. So then it must be called mechanical equilibrium. The system is in mechanical equilibrium. Okay, now chemical equilibrium. If the chemical composition of any system is same, chemical composition of any system is same in every space of the system and does not change with the time, then the system is in chemical equilibrium. If the chemical composition of any system is same with every space of the system, take a glass of water, okay, take a glass of water and show that the composition of the water is H2O. So the composition of the water H2O is same in every sphere of the system, okay. So then it is called the chemical equilibrium. If the chemical composition of any system is same in every space of the system and does not change with time, and with the time if we warm the water or if we cool the water, if we warm the water becomes steam. If we cool the water becomes ice. But the composition of the water, that is the H2O, it does not changes, okay, does not changes with the time, then it is the system is called in chemical equilibrium. The system is called in the chemical equilibrium, okay. State function of a thermodynamic system. State function thermodynamic system are pressure denoted by P, volume denoted by V, temperature denoted by T, internal energy denoted by E, enthalpy denoted by H, entropy denoted by S, Gibbs free energy denoted by G. The functions depends on the state of a system, okay. The system state, the system in which state, it depends on the functions, okay. This is called the state function of a system. System does not depends on them. This particular the functions depends on the state of a system. If the system like a glass of water, the glass of water is warmed, then the temperature must increase and volume of the steam, then the water is becoming the steam and then the volume of the steam is also increasing, okay. Internal energy of the water, internal energy, I will discuss in my next class the internal energy of the system must also increase, because with increasing the heat, the molecules of water in a glass of water are becoming warm, okay. So then the molecule are running from one position to another position very quickly, like this, they are running from this position to this position very quickly, okay. So then internal energy of the system is increasing very rapidly. So we can see that the state functions of a system depends on the state of a system. The system is in which state, warm, cool or any others, okay. So these functions are called the state function of a thermodynamic system.